Welcome to online classes of SHIVAJI group of institution. A student, myself Jiten Tripathi. Today we are going to explanation for the next topic of the chapter, periodic table and their periodic properties. Student, in last class we are discussing about the ionization energy and ionization potential, and now today we are going to explain. Next topic is electron affinity. Okay, so student, next is the electron affinity. Electron affinity. First we know about the definition of the electron affinity. Electron affinity is the energy released when an extra electron added to a neutral gaseous atom is known as electron affinity. What is the difference between ionization energy and electron affinity? In ionization energy required, and while in electron affinity, energy released. So required and released, they are two different things for the energy in these two definitions. So once more, energy released when an extra electron added to the neutral gaseous atom is known as electron affinity. So, definition is energy released when an extra electron added to a neutral gaseous atom is known as electron affinity. Now take an example. Neutral isolated gaseous system. This one is also neutral isolated gaseous atom. Same is as in ionization energy. Here also we take a isolated gaseous atom. Let me take an example. A is an element. Take whose gaseous isolated atom to add one more electron to form a negative gaseous and energy released, that is electron affinity. This is known as electron affinity energy. Okay. Now one more electron is also added in this anion gaseous. So what happened next? This form a double negative gaseous and electron affinity. This one is 1, this one is 2. Successive ionization energy, this is one is also successive ionization electron affinity. But here we make two different signs. First one is a positive and second one is a negative. What is the difference between these two electron affinity energy? Why first one is a positive and second one is a negative? Hold on, this one is an energy term. When we say enthalpy term, then first is a negative, second is a positive for enthalpy. But in case of energy term, first is positive and second is negative. Here one reasoning question arises in this topic, that how will you define, how will you explain that or what's the reason behind that first electron affinity is positive and second is negative, or first electron gain enthalpy is negative and second is positive. Why? These two different question are arises, but answer of both the question are same. Now we have to explain the answer for this energy positive, first positive and second negative is that when we add one initial first electron, then we done some work and supply some energy to the electron to add in neutral gaseous atom. After adding the electron, some amount of energy are released. So then input and output difference is the positive. Input and output, input energy and output energy difference for both, that is a positive. While we add second electron, then also we have to done some extra work. Why we done some extra work? Reason behind that, this is also negative ion, this is an electron. To a positively charged particle attract to each other, attract or repel to each other. So such repulsion force makes some extra work. Reason behind that, my object is to add one more electron in neutral negative anions. So to a positively charged closely, then we done extra work for this repulsion force. That's why input energy is more than output energy. That's why energy difference is negative. But in case of first one, input is lesser than output, so difference is positive. While in second case, input energy is more than output energy, that's why second is negative. While we are saying electron gain enthalpy term, then no other extra words are used to in this answer. Only you have to say first is negative enthalpy, electron gain enthalpy, while second is positive. Signs are changed only, nothing else. Okay, so this one is a electron affinity. Now come to its periodic trend. Periodic trends. So periodic trends, number one, in period. In period, what happened? When we are moving along a period from left to right, always we are moving in a period from left to right, then electron affinity increases. Why? Again one question arises, why electron affinity increases from left to right? Reason behind that, again, effective nuclear charge increases. Size of atom is surpassed during we are moving in a period, so that lot of energy evolve in a period, while in case of periodic trend in group, so when we are moving in a group from top to bottom, then electron affinity decreases. Why it decreases in a group? Reason for that, by one more extra cell is also added continuously when we are moving in a group from top to bottom, then difference between the nucleus and outermost cell is continuously increases. That's why electron affinity energy decreases. Lesser amount of energy required to shift one electron in that cell, outermost cell, in case of group. While in period, lot of amount of energy released when we add in along a period. Okay. So this is all about today electron affinity term, and it's a periodic train. Next topic for this chapter is electronegativity and metallic and non-metallic character. Okay, this is all about today. Best of luck for attending the class.